So, my dear kids, welcome back once again for this new topic, new chapter from physics part, and the topic is force and laws of motion. Okay, this is an interesting chapter, not like the last chapter. Okay, this lots of daily life examples we can use in this chapter. Okay? And as you told in the introductory video, this is my favorite chapter of 9th standard science. Okay, I hope for you also it will be very easiest, not easy, interesting chapter. It's an interesting chapter. Okay, we are studying about the laws of motion and all, formulated by the great legend Sir Isaac Newton and all. Isn't it? Just imagine after 400, 500 years, still the modern science are depending upon Isaac Newton's laws of motion. Anyway, you want to study those three, it's very easy. Laws of motion is very easy. Okay. So let us start. So what is this laws of motion? What is motion actually? See, force. First one, what is a force? For motion we need force. Force is defined as a push or a pull that changes or tends to change the state of rest or of uniform motion, or changes the direction or shape of an object. It causes the object to accelerate or add to their overall pressure. Force is basic cause of motion from rest. The limit or the unit of force is known as Newton. So you already discussed about force, what it is. Okay, it's a push or a pull, which will move something. Okay, which will move something, or which will stop something which is already moving, or which will accelerate, increase the speed of something, or decrease the speed of something. It will change the position, it will change its direction. Okay, it can change its shape also. That is called as force. Let us start with the definitions. Force. A force can be a push or a pull. For example, when we push open a door, you have to apply force to that door. You also have apply force to pull open a drawer. Simple thing. Automatic doors are there nowadays. I am not talking about automatic doors. If you have door in your home, anyway if you want to open it, you want to apply some force. Okay, maybe you want to pull or you want to push. Isn't it? If you want to open your windows, maybe you want to push it or you want to pull it. Sliding doors are there. If you are sliding also, you want to push or pull it. Isn't it? That is force. See, a drawer also same in your home. See, he is pulling out a drawer, he is opening a door. You cannot see a force, but often you can see what it does. Anyway, can you see the force? Can you see that strength? No. But we can feel it, isn't it? You can see what it does, what change is happening if you are applying that force. For example, to opening a door. To open a door, you are pulling the door out. But you cannot see that force, but you can see the door opening. Understand what it does, what change it made? It made that door into the from closing position to the opening position. That we can see, and we can feel that force also. Okay. Force can change the speed of something, direction of something, or its shape. For example, an elastic band gets longer if you pull it. So what all things force can change? It can change the speed. Okay, it can change the position. It can change the direction of a thing, and it can change the shape of a thing. For example, in the first case, it can change the position means kicking a football. Understand? And it can change the direction. Speed means accelerating a car or stopping a car by applying brake. Change direction means simply playing cricket or playing shuttle. Okay. The shuttle means what? You are hitting that shuttlecock here and there. Each time the direction is changed. How it is changed? Because you are applying force with the help of the shuttle bat. Isn't it? Yes, of course. Is it simple now? Yes, of course. Just go through the concept. Physics will be very, very simple. Actually, it's the basic things we are doing in our daily life. Let's see. Balance and unbalanced force. Already you know what is balance. Balance means something which is in control. Unbalance means something which is not in control. Okay. Let's see what is balance and what is unbalanced force. Anyway, today we will discuss about balance and unbalanced force example. After that, we will move to the laws of motion, next chapter. Aha, you seen who is this? This is the legendary scientist or a physicist, Sir Isaac Newton. See, born on 25th December on a Christmas Eve of 1642. That means almost 400 years from now. 400 years, 380 years from now, he was born and he formulated the laws of motion. Look how cute he is, isn't it? Is it beautiful? Anyway, we don't want to assess the beauty of the scientist. We want to study about the laws of motions formulated by him. Let's see what is balanced and unbalanced force. Just by finishing that, we will complete this class. Okay, and we will go through the laws of motion. You want to know what is balance and unbalance? Let's see. When two forces acting on an object are equal in size but act in opposite direction, we say that they are balanced force. If two forces acting on an object are equal in size but act in opposite direction, for example, two same size boys, okay, two same size, okay, same weight, same strength, everything same, they are pulling a rope, okay, both sides they are pulling from both sides. That means there won't be any movement because in both sides they are exerting equal amount of force, isn't it? Am I right or not? In the case of seesaw, which you are using in this park and all, if two equal forces is applied on the both side, means it will remain straight, isn't it? That types of force is called as balanced force. Okay, if the force of an object are balanced, or if there are no force acting on it, this is what happens. An object that is moving stays still. In that case, there won't be any movement of that rope or those boys, isn't it? And if pictures are there, okay, pictures are there, we will see. An object that is moving continuous to move at the same speed and it is same direction. If an object that is moving continuous to move at the same speed and in same direction. So if the force exerted by something in opposite directions are equal, then we can say that particular object won't move. Understand? It won't move. But in the case, see, if it is already moving and the force exerted by the both directions are same, then that continuous motion will go on. Understand? Like kilometers and kilometers it will move like that. Okay. Now the last part I think you don't understand this one, isn't it? Okay, let us see this example. We will discuss that with this example. See. What is this? We have a crate here. Crate means a small box of wood or whatever materials. I think this photo shows a wood. So it has a weight. Okay, because of the gravity, it has a weight. And we have a rope. We tied a rope to that particular crate or box. See, hanging object. What is the hanging object? You can study. What is the property of a hanging object? The force on this hanging crate are equal in size but act in opposite direction. The weight pulls down and the tension is in the rope pulls up. The force on this hanging crate are balanced. See, in this case, it is a bit twisty to understand. See, let it this be 10 kg of box. Understand? So to hang it, 10 kg or 10 kg or force equal to 10 kg weight must be exerted by this rope, isn't it? Otherwise it won't be hanged, it will go down. If we are applying more force, it will go up. Understand? If we apply more force, it will go up. So it is not balanced. If we apply less force, it will go down. Then also it is not balanced. Okay? Force equal to 10 kg of weight is exerted to this rope. That way it is hanging. Understand now? Understand now? For example, this crate is on the ground. Okay, the same two boys, one is standing here, one is standing here. They are pushing it. They are pushing it from both directions. Okay, their strength is equal, their weight is equal. This box will move. No, the box won't move because both are acting equal pressure or equal force on it. That's balanced force. Understand? If the strength of one boy is more means the box will move in this direction. So it will become unbalanced. Let's see next. Come on next. Unbalanced. When two forces are acting on an object are not equal in size, we say that they are unbalanced force. This example is very easy. Okay, unbalanced force in our daily life, lots of examples are there. Okay, if the forces on an object are unbalanced, this is what happens. Let's see. An object that is not moving starts to move. An object that is moving changes speed or direction. Simple example. Unbalanced force. See, both the boys are exerting force. The strength of one boy is much more higher than the another boy means. Absolutely that box will move 100%, isn't it? This is happening in the case of unbalanced force. When two forces acting on an object are not equal in size, we say that they are unbalanced forces. If the forces on an object are unbalanced, this is what happens. The object that is not moving starts to move. That time the force exerted by the both boys are different means absolutely that box will move in one direction. An object that is moving changes speed or direction also. The direction also will change, speed also will change. See, 100 Newton force is applied from this side, 60 Newton force is applied from this side. This you studied in the last chapter, isn't it? So this truck will have an unbalanced force because here 100, here 60. Here it is more, so this truck will move in this direction. Understand? And 40 Newton, 100 Newton minus 60 Newton, that will be the resultant force. Isn't it? Is that easy or not? Yes, of course it is easy. You already studied in the last chapter. Okay, that's it. That's only I will taking this class. Balance and unbalanced force. Just read that textbook. Notes and all I am not giving now. I will give afterwards. Okay. No, it is too early to give the notes. You just go through the video. Today there is no homeworks. There is no homeworks. Okay. Only read the textbook. That's the homework. And try to understand balanced force and unbalanced force. Okay. Mostly in our daily life we are seeing unbalanced force. Balanced force are very less in our daily day life. Okay, that's it, my dear kids. So just read the textbook and watch the video. Next day means tomorrow holiday Sunday. Monday we will start with the laws of motion. So till then, bye bye and Jai Hind. So Mithun Rai signing off from this part of the world. Bye bye, my dear kids. Jai Hind. Stay home.